So let's take another look or a recap of the ideas that we've looked at in this second day. We discussed how displacement is a vector, and remember, displacement is the straight line distance from a starting point to an ending point. And if you want to add multiple displacements, you have to add them as vectors. Adding vectors can be done a couple of different ways. If you just want to make a rough sketch, then the tip-to-tail method is a really good way to figure out how the vectors are pointing. So you take the second vector and put its tail on the tip of the first vector and then add them together. Or you can use the component method, which is a faster way to get a more exact answer. And that's where we break the vectors into their components and then add all of the x components together and then add all of the y components together in order to find the x and y components of the resultant vector. We also looked at velocity and how velocity is speed, but it's also direction, so it's a vector. We looked at the special case where you have constant velocity, meaning no acceleration, in one dimension, and in that case we can write down our constant velocity expression, that the change in position, which is the same thing as the final minus the initial position, is equal to velocity times time. Now this only works when the velocity is constant, when the acceleration is zero. We also discussed how acceleration was a change in velocity. You can get an acceleration by speeding up, slowing down, or changing direction. But if you have the special case where you have constant acceleration and your motion is in one dimension, then we can write down any of these constant acceleration equations and use whichever is most convenient for solving our problem. So this concludes the second day of summer general physics. Tomorrow, we'll start considering motion in 2 dimensions, and we'll also be looking at falling objects.